This is Andromeda, but not as you know it, not as a gentle smudge in the night sky, but as a sprawling city of 1 trillion stars, each one a sun, each with its own story. For the first time, we can see millions of them individually. This image, a masterpiece from the Hubble Space Telescope, is the largest portrait of another galaxy ever created. It reveals a history of shocking violence and helps us predict a cataclysmic future involving our own Milky Way. Let's explore this monumental image together. 1,000 years of discovery. How do you see a galaxy 2.5 million light-years away without a telescope? For centuries, it was just a smudge. The first person to write it down was Persian astronomer Abd al-Rahman al-Sufi, who in 964 AD described it as a nebulous smear in his Book of Fixed Stars, a foundational text in astronomy. He was observing from Isfahan, a location with dark skies we can only dream of today. For over 600 years, that's all it was. Then, on December 15, 1612, German astronomer Simon Marius aimed his new telescope at the smudge and became the first human to resolve it with more detail, describing it as looking like the light of a candle shining through horn. This was a crucial step beyond just seeing a cloud. Over a century later, in 1764, the famous comet hunter Charles Messier gave it the designation it still holds today, Messier 31, or M31, cataloging it to prevent other comet hunters from mistaking it for a new discovery. His catalog of things to not mistake for comets ironically became a list of the most spectacular deep-sky objects. These early astronomers were looking at the same object we see today, but they had no idea of the true scale of what they were witnessing. The Great Debate. Imagine thinking our own Milky Way was the entire universe. For most of human history, that's exactly what we thought. That all started to change in 1845, using a colossal 72-inch telescope he built himself, the Leviathan of Parsonstown. Irish astronomer William Parsons, the 3rd Earl of Ross, was the first person to see the distinct spiral structure in a nebula, which he observed in the Whirlpool Galaxy, M51. In 1888, amateur astronomer Isaac Roberts took the first ever long-exposure photograph of Andromeda, revealing its own stunning spiral arms. But this new evidence created a fierce argument. This question culminated in the famous 1920 Great Debate between astronomers Harlow Shapley and Heber Curtis. Shapley argued that the nebulae were nearby gas clouds, based on his recent and correct calculation that the Milky Way was far larger than anyone thought. He couldn't imagine anything existing so far beyond it. Curtis, on the other hand, argued that the sheer number of novae, exploding stars, seen in Andromeda suggested it was a stellar system of comparable size to our own galaxy, just incredibly far away. It was a clash of titans, with the very size and structure of the cosmos hanging in the balance. Hubble's revolutionary finding. One man, one discovery, and suddenly the universe became terrifyingly vast. That man was Edwin Hubble. In the early 1920s, the astronomical community was fiercely divided following the Great Debate. Then, in 1925, using the most powerful telescope in the world, the 100-inch Hooker telescope at Mount Wilson, Hubble settled the argument for good. He discovered special stars in Andromeda called Cepheid variables, thanks to the groundbreaking work of astronomer Henrietta Swan Leavitt at the Harvard College Observatory. It was known that the pulsation period of these stars is directly related to their true brightness, making them perfect standard candles. Leavitt's discovery was the key that unlocked galactic distances, though she received little credit in her lifetime. By observing how long it took these stars to pulse, Hubble could determine their intrinsic luminosity. By comparing their true brightness to how dim they appeared from Earth, he calculated their distance. His calculations placed Andromeda nearly 1 million light-years away, far beyond the accepted boundaries of the Milky Way. In a single stroke, Edwin Hubble proved Andromeda was a galaxy in its own right, vindicating Heber Curtis and forever changing humanity's place in the cosmos. A new portrait emerges. What does it take to create the single largest and sharpest image of another galaxy ever assembled? Well, it took years of planning, over 1,000 orbits of the Hubble Space Telescope, and the meticulous stitching of hundreds of individual snapshots. In 2015, a team of astronomers led by principal investigator Julianne Dalcanton released the stunning result of the Panchromatic Hubble Andromeda Treasury Program, or PAT. This image isn't just beautiful, it's actually a scientific census of our neighbor, captured across 6 different spectral bands from near ultraviolet to near infrared. The ultraviolet light reveals the hottest, youngest, most massive stars, tracing out the sites of recent star birth. The near-infrared light, on the other hand, penetrates through dust and highlights the cooler, older, and more evolved stellar populations. This range allows scientists to analyze the age, temperature, and chemical composition of the stars. The final image contains 2.5 billion pixels and resolves over 100 million individual stars across a 61,000 light-year stretch of the galaxy's disk. The dataset is so vast it would take thousands of high-definition screens to view at full resolution, a treasure trove for decades of future research. The Ring Mystery. Look closely at Andromeda, and you'll see something strange, ghostly rings of dust and stars that really just shouldn't be there. For years, these features puzzled scientists. In the incredible Hubble mosaic, you can clearly see a massive elliptical ring of star formation in the outer regions, populated by hot, young, blue stars. This is bizarre because in a normal spiral galaxy, star formation follows the density waves of the spiral arms. A distinct offset ring points to a sudden galaxy-wide disturbance. In 2006, using the powerful infrared vision of the Spitzer Space Telescope, a team of researchers led by astronomer David Bloch discovered a second, hidden inner dust ring. This one had been hiding in plain sight, as its dusty nature made it invisible to optical telescopes, but glowed brightly in the infrared. Two distinct rings meant this couldn't be a coincidence. David Bloch himself offered a powerful analogy, describing the dust rings as being like ripples in a pond. And what causes ripples? An impact. This discovery was the first major clue that Andromeda's past was far more violent than its serene appearance suggests. Scars of ancient collisions. Those rings aren't just ripples, they're the crime scene of a galactic hit and run that happened hundreds of millions of years ago. Following the discovery of the two dust rings, David Bloch and his colleagues ran detailed computer simulations to figure out what could have created them. These aren't simple animations, they are complex models accounting for gravity, gas dynamics, and star formation across billions of particles. The evidence pointed to a dramatic conclusion, a head-on collision. The culprit, they proposed, was one of Andromeda's small companion galaxies, Messier 32, or M32. According to their models, about 210 million years ago, M32 plunged directly through the disk of Andromeda, like a cosmic bullet. This cataclysmic impact would have generated enormous shockwaves of gas and dust that expanded outwards from the point of collision. These shockwaves compressed interstellar gas, triggering the massive bursts of star formation that we now see as glowing rings of young blue stars. The simulations were so precise they even recreated a conspicuous hole in the outer ring, where the expanding ripple interacted with a spiral arm, a stunning piece of confirmatory evidence. The giant southern stream. The rings were just the beginning of the story. Deeper analysis revealed a wound far larger, a river of stars torn from a cannibalized galaxy. While too dim to be seen clearly in the main Hubble image, other surveys have revealed a mammoth feature called the giant southern stream. This is a vast trail of stellar debris that stretches for hundreds of thousands of light-years from Andromeda's southern disk out into its halo. First identified by a team including astronomer Rodrigo Abada, this stream is a dissipationless structure. Its stars are cold, contain no gas, and move together like a ghostly river, their paths dictated solely by gravity. Finding such streams involves meticulously analyzing the motion and chemical composition of millions of stars to find the ones that move together and share a common origin. It's kind of like finding a single drop of dye that has been stretched across an entire ocean. The sheer scale of this structure, far larger than Andromeda's visible disk, is undeniable evidence of a major merger event, something way more destructive than the punch-through collision that created the rings. M32, the smoking gun. What if the tiny galaxy responsible for the rings was also the leftover core of a much larger victim? That's the stunning theory that connects the giant southern stream to the dwarf galaxy M32. In a 2018 study, researchers Richard D'Souza and Eric F. Bell proposed that M32 is not a true dwarf galaxy, but actually the stripped compact core of a much larger galaxy they named M32P. Their simulations show that M32P once the third largest galaxy in our local group, merged with Andromeda between 2 and 5 billion years ago. During this cosmic collision, the powerful tidal forces of Andromeda stripped away M32P's outer, less dense layers of stars and gas, which then formed the giant southern stream. Only the dense central core survived the encounter. The collision also triggered a massive burst of star formation, which finally explains a long-standing mystery: why Andromeda has so many intermediate-aged stars. M32 itself is unusually dense and compact, perfectly matching the profile of a stripped core, a cosmic smoking gun pointing to Andromeda's history of galactic cannibalism. Satellites and secrets. Andromeda isn't alone. It's the gravitational master of a cosmic court, surrounded by dozens of smaller dwarf galaxies, and each one holds a piece of the puzzle. While the M32P merger was likely the most significant event, it almost certainly wasn't the only one. Thanks to the incredibly high resolution of the combined Hubble data from the PAT and FAST surveys, astronomers can now hunt for more subtle clues. Researchers like Anil Seth specialize in this kind of galactic archaeology, using faint stellar streams to reconstruct a galaxy's merger history. The FAST survey, which extended the original program to Andromeda's southern region, was crucial because that part of the galaxy appears far more disturbed. This data also helps tackle puzzles like the satellite plane problem, a mystery where many of Andromeda's dwarfs orbit in a thin co-rotating plane, which challenges standard galaxy formation models. The full story of Andromeda's violent past is likely a complex tapestry woven from one major collision and dozens of smaller skirmishes, a story we are only just beginning to read. Our galactic future. For years, we've been told our galaxy is on a direct collision course with Andromeda, as the two largest galaxies in our local group, the Milky Way and Andromeda, are rushing toward each other at over 110 kilometers per second. In 2012, a team led by Roland van der Marel used Hubble to painstakingly measure the sideways proper motion of Andromeda, confirming a head-on collision was inevitable in about 4 billion years. However, this is not a collision of solid objects. Individual stars are so far apart they will likely not hit each other. Instead, the two galaxies will pass through one another, their immense gravity distorting each other into long, spectacular tidal tales of stars and gas. After a few chaotic passes over hundreds of millions of years, they will settle and merge into a new, larger, and likely elliptical galaxy, which some have nicknamed Milkomeda. More recent data from the ESA's Gaia mission, which is mapping the positions and motions of billions of stars with incredible precision, is continually refining these predictions, giving us an ever clearer picture of our ultimate galactic destiny. This breathtaking image from Hubble has transformed our view of Andromeda from a serene spiral into a dynamic and violent galaxy with a dramatic past. It's a cosmic crime scene, a history book, and a crystal ball all rolled into one. The 10-year effort of the PATI and FAST programs has given us an unprecedented census of our neighbor, but the story is far from over. As scientists continue to mine this incredible dataset and new telescopes turn their gaze toward our neighbor, we will undoubtedly uncover even more secrets. We are, after all, neighbors, and in a few billion years, we might be getting a whole lot closer. If you found this cosmic journey as fascinating as I did, don't forget to like, subscribe, and hit the bell icon. Thanks for watching InnoVision Tech.